Hi y'all, today we're learning about logarithms. So you may have seen this in the past, but a logarithm is anything that uses the abbreviation log and might have a base number here and then a number here like that. So this would be a logarithm. A logarithm is a fancy way of writing an exponent. So what we see here is the log is here, the base is what this little number is called. The number is here, and then it equals an exponent. So we have a bunch of examples here that are written in logarithmic format. So that means they have the log there. We're going to convert them into exponential format. So you'll see here that a few of them have been done for us. But essentially what we do is we say, okay, the base to the power of this number gives me that number there. So the base to the power of the exponent gives me the number. So the way it looks is like this. So like 3 to the power of 3 is 27, right? So we would write it 3 to the power of 3 equals 27. What's written in blue here is the exponential format and the logarithmic format is in black. So we could say, okay, 2 to the power of 4 gives me 16. So I'd write 2 to the power of 4 gives me 16. You could do this another way. So some mathematicians do this a separate way. They know that the log base 2, the inverse of that is taking 2 to the power of log 2. So these would kind of like cancel and cancel, right? But that means what we do on one side, we have to do on the other as well. So here we'd have 2 to the power of log base 2, 16 equals 2 to the power of 4. And this would cancel 2 and 2, give me 16 equals 2 to the power of 4. Notice that's exactly what we had before. Some people like to write it this way. I like to do the loop-de-loop. Either way works. So for example, in this one here, we could say 5 to the power on both sides. 5 and log 5 cancel. 125 equals 5 to the power of x. Right? Alternatively, if you like it this way, 27 to the power of x equals 9. 27 to the power of x equals 9. So you can do it either way. You just have to pick one. So we could say 36 to the power of 1/2 equals 6, which we know to be true. It's 1/2. It really means square root. Go ahead and take a look at these. You can pause the video and try these ones on your own, and then we will come back and I'll have a new answer for you. All right, we're back. So you can go ahead and check your answers for these ones. And then you might have gotten to these two and been like, wait a second, there is no base number here. How can I get started with this? So there are actually two types of logs. There is the common log, right? And the common log is when you have a log and there's no base written. The base is actually 10. So we could put a 10 here and we would say 10 to the power of x is 100, right? So this would be our log form and this is our exponential form here, right? So this is called a common log. We could have also written, that's why you also see this one here as there's nothing there, right? It would be 10 to the power of x equals 1000. So our common log has a base of 10. Additionally, from time to time, we might see what's called a natural log. So it's ln, right? So this is an L, not a capital I, but ln, and it has a base of the number e. You might be like, Miss, why the number e? That is, or like, why would I say the number e? E is a number like pi, something like 2.7. It's like 3.14159, how it goes on forever and ever and ever. This is the same type of number. It's roughly 2.7, right? So when we have a natural log, the ln log, the base is e. So we see e to the power of x gives me 5. E to the power of x is 5. If you like doing it the other way, you could say, okay, take both sides with that e to the power of that, cancel, cancel, 5 is equal to e to the power of x. Okay, so you can do it either way with the natural logs as well. Okay, so in this first part, we converted from logarithmic format into exponential format. Now we're going to talk a little bit in part 2 about estimating logs. So in order to estimate logs, um, we want to figure out like 3 to the power of what is going to give me 81. You might be thinking already, well, 3 to the power of what gives me 81? You might say, oh, well, 3 to the power of 4 is 81. So the answer to this log base 3 of 81 is the number 4. That's how we can estimate them. It's called evaluating, right? If you wanted to do this in a calculator, there are a couple ways. On old school calculators, you would do log of the number over log of the base. So what that would look like is log of 81 over log of 3. So you would go to functions here, go over to miscellaneous, and then go to log, or you can actually type just log, right? So log 81 divided by, show you that way, log of 3, log of 3, and you would get your answer 4, right? So we see this number is 4. Since we have fancy calculators and the yellow calculators at school did the same thing, you can go to functions, go to miscellaneous, and you'll notice there's a log A here. If you click that one, that will let you put in a little number there. So we would do 3 as our base and 81 there. So we get the same number 4. So you can use either way. This first one's called change of base, and this one is just putting it into our formula the way it is. So that one is less of estimation, right? Because we just know 3 to the power of 4 is 81. But 3 to the power of something gives me 36, right? I know that 3 to the power of 3 is 27, and 3 to the power of 4 is 81, right? But there's no 36 there, right? 36 is somewhere in the middle. 36 might be 3 to the power of like 3.1 or 3.2, something close to 3 because 36 is close to 27. So I wrote that out here in this text here. You can use this for part 2 when you're working on your assignment. If I want to calculate the exact number, I'm going to go ahead and go to my calculator. I could try estimating like 3.1. Whoa, 3.1. Like that, or 3.2, something close there, right? But more easily, I can just use my log base 3 of 36. So the exact answer is 3.262. I'm going to use 3 decimal places, and I'm going to round this one up, right? Go ahead and take a moment, try to estimate what it was, or what 2 numbers it is in between, and then go ahead and use your calculator to find the actual one there. You can pause. All right, go ahead and check your answers here. And then you can see how I typed these into the calculator here so you could get your exact answers. So estimations and exact numbers. Cool. So far we have converted logs from logarithmic format to exponential format, and we've estimated some logs. And now we are going to solve some equations. So let's pop in here. Go ahead and leave my calculator up. So in order to solve for x, I'm going to use my same either loop-de-loop or power as I was having. So I'll show you both for this first one. So I have log 9x equals negative 2/3. So loop-de-loop, 9 to the power of negative 2/3 equals x. 9 negative 2/3 equals x, like that. I have 2 options at this point. I could say this is 1 over 9 to the power of 2/3. I know that the 3 is going out in front. So I have the cube root of 9 squared over 1. 9 squared is 81. Cube root of that is 3, cube root 3 over 1, something like that. right? I could do that math that way if I wanted to. However, since I have my handy dandy calculator, might as well use it. So I'm going to do 9 to the power of negative 2 over 3. I'm going to get this decimal here. If you're using decimals, you're going to use 3 decimal places. So 0.231 would be your answer there, right? If you don't love that version, you can also do it another way, which is using the powers, right? So raise this side to the power of that, 9 to the power of this, 9 to the power of log 9 are going to cancel and drop down just x equals 9 to the negative 2/3. Put it in your calculator, you're going to get exactly the same thing, right? So here we're just trying to get x by itself. So we get rid of the log. All right. From here on out, you can choose which way you want to go. You should always get the same answer. So if I have something like this, I have the natural log of x equals 3. So I know this is my base of e. I have e to the power of 3 gives me x. E to the power of 3 gives me x. X is isolated. It's going to go to my calculator. Here I can find e right here. It'll tell me that e is equal to 2.718, et cetera, et cetera, et cetera. I'm going to go ahead and take that to the power of 3, and I get x equals 20.086. Right? Remember to round when you have your thousandths place. Right? Quickly, just something like that. All right. For this one here, we have log 25 of 5 root 5 equals x. I'll go ahead and try the other way this time. So 25 to the power of this, 25 to the power of that. This will cancel. 5 root 5 equals 25 to the power of x. I'm gonna, since I have like, they look like similar bases here, I'm gonna show you 2 separate ways. The first one that I'm gonna show you is I could say, okay, 5 root 5 is the same as 5 times 5 to the 1/2. And 25 is the same as 5 squared with that x there, right? Notice I'm trying to make my bases the same here. I know this is 5 to the power of 1, and since these are being multiplied together, I know this is like 2 halves, and 1/2 would make 3 halves altogether. Remember, I add my exponents, so I'd have 5 to the power of 3 halves equals 5 to the power of 2x. My bases are the same, so I would have 3 halves equals 2x. Divide by 2. I would get x equals 3/4, or if I did 3 divided by 2 divided by 2, divided by 2, I would get, oh, that is funky because I just did 3 divided by 2 over 2, but that's not actually what I wanted. I want 3 halves, right? This divided by 2. Right, so we get a slightly different answer, 0.75, as we can see here, 0.75, 0.75. This is one way to do it. If you really love exponents, you could do it this way. A second way to do it is if you had 5 root 5 equals 25x. Let's get rid of that root right away. So let's go ahead and square this, and we can square this as well. So 5 root 5 times 5 root 5 would be 5 times 5, 25, times square root of 5 and square root of 5 are going to make 5, the whole number 5, equals 25 to the 2x power, right? 25 times 5 is 125 equals 25 to the 2x. And now I'm going to go ahead and make my bases the same. This is 5 root 3. This is 5 squared, 2x. Sorry, 5 to the 3rd power, 25 turning into 5 squared with 2x. So I have 5 to the 3rd, 5 to the 4x. My bases are the same, So I have 3 equals 4x, bringing my exponents down. Divide by 4, you get x equals 3/4. Wild, but we get the same answer, right? So you have lots of strategies. Feel free to use them. We should still get the same answer. Cool. All right. Well, let's try some less complicated ones. So we have log base 3, 2x plus 1 equals -3. So 3 power of -3 equals 2x plus 1. I'm going to use my calculator wide array. 3 to the -3 is going to be 0.037 ... equals 2x plus 1. I'm going to write the ... because I don't want to forget that there's all of these numbers here. I'm going to use this entire thing in my calculation. So I'm going to do -1, subtract 1 on each side. We get roughly negative 0.963-ish equals 2x, and then divide by 2. I'm going to go ahead and take this number and divide it by 2. I press the parenthesis in order to make the parenthesis go around what I have, and then divide it by 2. So I get x equals negative 0.481. The reason I want to do this all in my calculator like this is 1, it's a little easier, but 2, I don't want to do, if I do this, and then I'm like, oh, that's roughly 0.03037. And then I'm gonna add 1, and I get 1.037, and then I'm gonna divide by 2. I could end up getting, oh, I should have subtracted 1. Just kidding, let's subtract. So I have negative 0.963. I could end up getting a slightly different number, which would have resulted in me writing 4.82, which would actually be the wrong answer there, right? Because that 5 would make me round up. So I don't actually notice that this number is different from what we actually got, which was this number here, right? So we want to keep it as exact as possible. So not this one here. Cool. All right, let's go ahead and try this one. We have log base 2 to the power of that whole thing equals 9. So log base 2 plus x, or x plus 2, equals 9. Now, I know that there are actually 2 separate ways to do this. Let me show you again. So, more complicated way. I know that when exponents are being added, I really have 2 to the x times 2 squared equals 9. I'm going to go ahead and divide that 4 on both sides. Gives me 2 to the x equals 9/4. Right? But then I have to say, okay, I'm still estimating here. This is not going to be a helpful direction for me. So I'm going to go back to the drawing board. I'm going to say, okay, what do I know here? I do know that I can do this in my calculator. So I can go here and say log base 2. Let me go ahead and use my functions. Log base 2 of 9 is 3.1699999 equals x plus 2. All right, well, that's super easy. Go ahead and subtract 2 on both. So I'm going to go ahead and say subtract 2, and I get 1.1699 would add up, round up to 70 equals x, and that is my problem. Right. So anytime that you have a log with 2 numbers here, you can go ahead and actually like simplify it. It's different than these other ones because x was in this problem, x was in this log, x was in this log. And over here, I didn't have x's in this log. So let's try a third way, right? This third way here would have been to go ahead and go straight to my log. So log 25, 5 root 5, 0.75 right away. So I could have had 0.75 equals x. Whew, that would have been much easier. So be careful when you have the log already has a number here and a number here. Right? If you have two numbers, you can calculate it in your calculator. Right? So 3 separate ways we could have done this problem. All right, let's do one last problem. So x is in our log, so we have to use our strategy. I know ln always has a base of e, so e to the power of 5 equals x plus 3. I'm going to go ahead and subtract 3 on both sides. I get e to the power of 5 minus 3 equals x. So we go here, e to the power of 5 minus 3. I get 145.413 equals x. This is my answer here. Whew. So we had a lot of solving here, lots of different methods. Feel free to use your creative streak. Ask any questions you have. Thanks, y'all.